Okay, the process we just discussed was called Gaussian elimination, named after the mathematician Gauss who developed this method. Now, another mathematician named Jordan expanded on this and said, hey, if we take this a little bit further, we don't have to back substitute. And so this became known as Gauss-Jordan elimination. So in Gauss-Jordan elimination, which honestly is probably the most common one, so developed by these two mathematicians, we want to get the matrix not in row echelon form, but in reduced row echelon form to solve it. So remember, reduced row echelon form is all of your leading coefficients of 1. Not only are there zeros everywhere below each leading coefficient of 1, but also zeros above it. Okay? And it comes out really nicely. Now, you'll notice that I have crossed out the problem in your notes. Some Gauss-Jordanian elimination can get really ugly, and the one here does. It gets into a whole bunch of fraction things, and it would be a terrible problem to teach you how to use Gauss-Jordan elimination for the first time. So that's why I've written this new problem in blue over here, way easier. So we're going to start with that one instead. Okay, so we're going to start out the same way. We're going to make our augmented matrix. 1, negative 2, 3, 9, negative 1, 3. There's no z term, so 0, negative 4, and 2, negative 5, 5, 17. Okay, and just remember, this is an augmented matrix. We don't normally write those little dashed lines. So our goal is to get a leading coefficient of 1 and zeros everywhere else in that column. Okay? Now, we've already got the leading coefficient of 1 here, so we're just going to leave row 1 alone. And let's work on row 2. So we'll leave row 3 alone right now. Okay, so to get row 2, well, you'll notice that right over here underneath the 1, there's a cursor here somewhere. 1 plus negative 1, that's going to be 0. So if we just take row 1 and add it to row 2 and put that over here, we should have something pretty nice to start with. So we're going to take row 1 plus row 2 and write our result over here. So 1 plus negative 1 is 0. Negative 2 plus 3 is 1. 3 plus 0 is 3. 9 plus negative 4 is 5. Okay? Now, our goal is still to get a 1 here and zeros everywhere else. So we've accomplished that for rows 1 and 2, so those are fine. We're going to leave them alone. 1, negative 2, 3, 9, 0, 1, 3, and 5. So now what we'd like to do is get rid of that 2. Now, think about your elimination. If you multiply the top row by negative 2 and add the top row and the bottom row, that's going to do it. So what I'd like to do is take 2 times row 1 plus row 3. Okay? Now, you may be able to do this in your head, but if not, you can use the little green numbers that I kind of sketch in here. I'm multiplying row 1 by 2, so these are my new numbers, and I'm going to add that to the bottom row. Okay, so 2, wait, that doesn't work. We need to multiply it by negative 2. Good catch. Negative, positive, negative, negative. There, that was a little better. Now, negative 2 plus 2 will give us 0. 4 plus negative 5 will be negative 1. Negative 6 plus 5, negative 1. And negative 18 plus 17, negative 1. Okay. So we have accomplished in column 1, we've got a 1 as our leading coefficient, all zeros everywhere else. Our next goal is right here. We want to get a 1 here, and we want zeros above and below it. Okay, so this is the difference in reduced row echelon form, is we want zeros both directions. Okay, so we are going to leave row 2 alone. So I'm going to write that down over here. 0, 1, 3, 5. Let's work on row 3, because that looks really easy. So right now I'm going to leave row 1 alone. And you'll notice that if over here, if I just add row 2 plus row 3, those are going to take care of it, okay? So row 2 plus row 3, we have 0 plus 0, which is 0. 1 plus negative 1, 0. 3 plus negative 1, 2. And 5 plus negative 1 is 4. Okay, now we're still working right here. We've got a 0 below it, which is good, but remember, we also want a 0 above it. So we are going to leave row 2 alone. We're going to leave row 3 alone. We are only transforming row 1. Okay? So what we need is we need to take 2 times row 2 and add that to row 1. Okay? So I'm going to take 2 times row 2. So this is going to be a 0. This will become a 2, a 6, and a 10. Now we're going to add that to row 1. Okay? So 0 plus 1 is 1. 2 plus negative 2 is 0. 6 plus 3 is 9. 10 plus 9 is 19. Okay. Now we have accomplished our first 2 columns. You see we have 1, 0, 0, 0, 1, 0. This is actually looking really good. Here's our next goal. We want a 1 there, zeros all above it. So let's actually start by making that a 1. It's going to make our calculations way easier. Okay, so we're leaving row 1 alone. We're leaving row 2 alone. And here we're just taking half of row 3. So divide all those by 2. We get 0, 0, 1, 2. Now, if you wanted to use back substitution, you would be all set to do it here, but that's not what we're doing. Okay? Remember, our goal is to get a 1 there and zeros everywhere above it. So we want to leave that bottom row alone, 0, 0, 1, 2. Now, let's work on row 2, which means right now we're going to leave row 1 alone. So we need a way to get rid of this 3. Everyone see the 3 there? I'll get my cursor so we know what we're talking about. There it is. This 3. Okay? So if I multiply this row by negative 3 and add these together, that will eliminate that. It'll be fantastic. So what we're doing in this elementary row operation is we're taking negative 3 times row 3, and we're adding that to row 2. So in green, I'm going to write, I'm multiplying my bottom row by negative 3, 0, 0, negative 3, negative 6, and I'm adding those green numbers to row 2. So 0 plus 0 is 0, 0 plus 1 is 1, negative 3 plus 3 is 0, and negative 6 plus 5 is negative 1. Okay, we're still working right here. We want zeros all the way above it, so now we need to deal with that 9. So we're going to leave the bottom row alone. We're going to leave the middle row alone. Oh, it looks like a 12. It's really not. Okay, and our goal is that 9. Well, let's take a look at this. If I take my bottom row and multiply it by negative 9 times row 3, and add it to row 1, that should do it. Okay, so what I'm doing is I'm taking negative 9 times row 3. That's going to make this 0, 0, negative 9, and negative 18. I'm going to add those green numbers to row 1. 0 plus 1 is 1. 0 plus 0 is 0. Negative 9 plus 9 is 0. Negative 18 plus 19 is 1. Okay? And now it is in reduced row echelon form. Notice we have the 1 as our leading coefficient right here, all zeros. Then a 1 in the middle, all zeros above and below, a 1 here, all zeros above. And remember, this is a system of equation. This is an augmented matrix. Okay, so our top row tells us that x plus 0y plus 0z equals 1. Our second row tells us 0x plus 1y plus 0z equals negative 1. And our bottom row tells us that 0x plus 0y plus 1z equals 2. That is our solution. And that's what's so cool. Once I know this process doesn't feel fantastic right now, but once you get fluent in this process, it's a really simple way to reduce these things, especially if you have more than 3 variables.